With rich client-side applications becoming increasingly popular, a common question is, should I use Rails if all I needed to do is provide a JSON API? Well, if you're faced with this question, check out the Rails API gem by Rails core member Santiago Passerino. The README here goes into detail and describes what Rails gives you that is useful if you're just building an API. Now, Rails is very modular, and this gem provides a generator for creating a streamlined Rails application that strips out everything that you might not need if all you're doing is building an API. Well, let's give this a try and see how it works in this episode. First, I'm going to install the gem called Rails API. And next, because I'm running Ruby env, I need to run the rehash command to give me access to the binary. So now I can run the Rails API command provided by the gem to create a new application just like I would with the Rails command. I'll call it to do. So this command generates a streamlined application designed for providing an API. Let's take a closer look. One of the major differences you'll notice is that the app directory is much simpler. There's no views or assets directory here. And if you check out the application controller that is generated, it now inherits from Action Controller API, which is quite a bit lighter weight than Action Controller Base, and I'll go into more detail on that later. Now, another major difference is inside of the gem file. You can see the Rails API gem is included in here, and there's no assets group. Now, the jQuery Rails gem is still here, but you can safely remove that. It won't be included in future versions of Rails API. Another change is how the generators work. For example, if I try generating some scaffolding here for a task model and give it a name, it doesn't generate nearly as many files because it's not generating any templates or assets. So let me migrate the database here so we can use it. Now, if we take a look at the task controller that was generated by the scaffold, you can see that it's only rendering a JSON response. It's not designed to render an HTML view or user interface. It's just an API inside of this controller. So if we try visiting the tasks path through the browser, we just see the JSON output, which is an empty array because we don't currently have any tasks. Now, if we wanted to present a user interface for creating tasks and managing them, that is expected to be done in the public directory or even outside of the Rails application entirely. The Rails app just handles the API. So for the purposes of this application, I'm going to go into the public directory here and replace the contents of the default index file with one that will list out the tasks and allow me to create some with a dabble of JavaScript and some CSS all in line on this file. But of course you can structure it however you want. So going to the root of this application, I now have a to-do list page where I can add an item. So let's say paint the fence. And then when I add this, it's just going to add it to a list. And I can even reload here, and it's going to fetch the item from the Rails application and display it in a list here. Now this is all done with some jQuery here with a call to get JSON to fetch the tasks and a call to post to create a task. Now I kept this example really simple, but you could go with a full client-side framework such as Backbone.js if you wanted to. Next, I'm going to show you some of the things that the Rails API controller leaves out. Let's say we want our API to respond in different formats, such as both XML and JSON. Normally in a Rails controller, we could add a respond to block with a format passed in here, and we could say both a JSON and XML, and then have a little block in here which renders either one separately. So we'll just render XML in here. Now let's try this out. Now when I visit the tasks.xml path, I expect to see some XML response, but it says undefined method respond to. So the Rails API controller is missing a number of features to make it lighter weight, but you can easily add them back if you need to. So here we just need to go into the tasks controller and include a module called Action Controller MIME Responds. Or we could include this directly into the application controller so that every controller has this respond to ability. And reloading the page, and now it works. We get our XML response. Now if you check out the Rails API README, it gives you a list of modules that you might want to include. And you can see the MIME Response module here for the respond to functionality. So you might want to include translations, HTTP basic, and so on. Still, that isn't the full list of modules. If you want, you can check out the source code and compare the modules included in the Rails API controller with those in Action Controller Base. And if you included all the various modules from here, then you would basically duplicate the same functionality of Action Controller Base. But this way you can pick and choose exactly what you want. Now, sometimes you need to do more than just include a module into the controller. For example, going back to the README here, it tells you if you want to add cookie support, you need to include the module and add in some rack middleware. So this brings up an important point. Not only does Rails API slim down the controllers, but the rack middleware stack as well. So if we go into our Rails application and run the rake middleware command, we'll get a list of middleware that is used, and this is noticeably shorter than a full Rails application. What's missing here, you might wonder? Well, I exported a list of both kinds of apps so we can run a diff on this for the API middleware and a full middleware stack. And so here you can see we're missing 5 pieces of middleware: method override, cookies, session, flash, and best standard support. Now if you're wondering what this middleware does, check out episode 319 for details. Now if we wanted to add back in some functionality such as the cookie support, we'll need to add the middleware and include the controller module. Now I'm going to add the cookies middleware back in through the application config file, and I'll just paste in the code for doing this. Now I think it's a good idea to try to maintain the same order that it is in the full stack, so I'm going to use middleware.insertAfter to add the cookies middleware after the query cache middleware, which is where it normally is. And then going into the tasks controller, I can add a line in here to include the action controller cookies module to get that cookie behavior in. Now you'll need to restart your app for the middleware to take effect, but then reloading the page here, and it doesn't work. I get an error saying helper method is not defined for the tasks controller. And this brings up an important point. Some modules depend on other modules, so in this case the cookies module depends on the helpers module existing, so you'll need to add that as well. And now reloading the page, and it works. Now you'll be able to interact with cookies just like you would in a full Rails app. Next, I want to talk about some other gems which can help you build a JSON API. Now I've covered both JBuilder and Rabble in previous episodes, and these gems will render JSON using Vue templates, which goes a little bit against the grain of Rails API, but still you can use them fine here. Let me show you using Rabble. You'll need to run the bundle command to install it, and one thing you'll notice, our app directory doesn't have a views directory, so we'll just need to make one because Vue templates are how Rabble works. So we'll need to make a views tasks directory and then a new file in here, and this should be called index.json.rabble. And here I'll just fill in the Rabble template telling it to render the tasks as a collection, and the attributes should be the ID and name attributes. And then going into the tasks controller, we need to change this JSON rendering behavior so that it renders out that template. Now in a normal full application, we could just remove this render call entirely and it will implicitly fall back to rendering a template. But in a Rails API app, this expects explicit rendering behavior. So we could say to render out the index template like this, but actually you could just remove this entirely and just call render without passing any arguments, and it will render out the template matching that current action. Now you'll need to restart the app for it to pick up that views directory, but once you do, you can go to tasks.json and it will return the JSON response rendering it through Rabble. Now if you want implicit rendering back, you can include a module called implicit render, and that means we don't have to call the render method anymore, and if we had an XML template, we can just comment out this entire respond to block because it would detect the format and render the proper template automatically. And try this out by reloading this page, and it still works. So this is getting closer to a full Rails application here because we're doing implicit rendering of Vue templates. Now a good question to ask is, if I'm adding all of this functionality back in, is it still worth going with the Rails API gem? At this point, I would lean towards going with a full Rails app because we are doing Vue rendering and so on, even though we are just rendering an API. But it really comes down to each application's requirements and how much of the Rails stack you plan to use. Now one thing I haven't done is any performance or memory consumption tests to compare a Rails API app with a full application. If you want to do that, that'd be awesome. Just post in the comments to share it with others. Now before I go, I want to give another shout out to the Rails API README. If you are making a JSON API, I highly recommend you read the section on why use Rails for JSON APIs. It goes into a lot of detail on what Rails does provide that you may not realize outside of HTML rendering. Well, that's it for this episode on Rails API. Thanks for watching. This week's Pro episode is on Rails modularity. There I will show you how the smallest Rails application works, and then I'll cover how to whittle down a full Rails application stack into just what you need. To watch that episode and all other Pro and Revised episodes, just head on over to railscast.com/pro and then sign up there for just $9 per month. With Amazon EC2, we can deploy our Rails applications into the cloud. This allows us to scale on demand by adding and removing server instances. Now, deploying directly to EC2 can give us a lot of control over the server setup and be more affordable than other cloud services. However, it does put a lot more work and responsibility in your court. Thankfully, there's a nice gem to help us out with this called Rubber. This is a Ruby gem written by Matt Conway, which builds upon Capistrano and allows you to easily deploy to Amazon EC2 and manage it with only a few commands. Let me show you how it works in this episode. I'm going to start by creating a new Rails app that we can deploy. I'll just call it blog, and I'll set the database to Postgres because that's what I want to use in production. And then inside of here, I'll just generate some scaffolding called article and give it a name and a content column, which will just be a text type. All right, so now that we have an app to deploy, let's set it up with Rubber. First, I'll run gem install Rubber to install the gem. And this will give us access to the Rubber command, which we can use to set up our project. Now, if you have trouble running this command and you're on ruby-env, you might need to run ruby-env rehash so that you can execute that command. So now we need to run the Rubber vulcanize command to prepare a Rails app for EC2 deployment. And we need to pass in here the name of a template we want to use to tell it how to set up the production environment. I'm going to use one called complete passenger Postgres, and this will just generate a number of files. Now, the reason this generates so many files is because all of the server configuration will be inside of this application in one place. So this makes it much easier to manage all the production server config. Now, if you check out the source code for Rubber, in here you will find a templates directory, and in here it lists out all of the templates that Rubber provides out of the box. And here's that complete passenger Postgres template that we passed to the vulcanize command. So you can pass any one of these to that command to really customize your production stack. And you can even check out the source code for each one to really see how they work. You can see this one just depends on a couple of other templates that it ends up calling. So you can create your own templates here as well. Now let's take a closer look at what files were generated in our application when we ran that template. Under the config directory is a Rubber directory where most of the files are located. And inside of here you can find some Ruby files which are primarily Capistrano recipes, and you won't need to modify those directly too much unless you want to change which commands are run on the server. The YAML files, on the other hand, are more just configuration files that are designed for you to change. For example, RVM will be set up on the server, and here you can customize which version of Ruby it should install. And if you check out the passenger config, you can see how many app instances it will allow. Now, if this isn't enough configuration, you can find the full configuration files under the role directory. Here we can see under the passenger directory that there's a passenger.conf file where we can fully customize how passenger is set up with Apache here. So this way, you have full control over how your production is set up, but if you don't know what to put here, just leave it at its defaults because those are pretty good. One thing you will need to change, though, is the rubber.yaml file. Here we can set the name of the application, I'll call it blog, and the admin email and the domain name and so on. I'll leave those at their default. We will need to change the access information for Amazon Web Service. Now, if you aren't set up for Amazon EC2, don't worry, it's pretty easy. Let me show you. Going to the Amazon EC2 page, just click Sign Up Now, and then you'll need to log into your Amazon account, and then follow the rest of the steps. After you're done, you just go to your account and go under the Security Credentials page. So this will give you the information you need to fill in. The account number is near the top here, just copy that, and then paste that into the account section inside of the YAML file. You'll need to strip out the dashes in that number as well. And then scrolling further down, you can find the access keys section. You can create a new access key if you want here, and this will give you a key ID, which you just need to paste into the access key attribute. And then you can click on Show to see the secret access key here. And I'll paste that in as well, just like that. The next thing we need to do is set up a key pair. And you can see the default name for this key pair is GSG key pair, but I think you can name it anything you want, but I'll stick with this. Now going back to the Amazon account, click on the Key Pairs tab, and scrolling down you can see there's a section for Amazon EC2 key pairs, and this is what you want to make. And you'll actually need to switch to the management console here, so clicking this link will go to the console. And then going to the left side of here, click on the key pairs section, and here you can create a new key pair, and give it a name. I'll name it GSG key pair just to stick with the default of rubber, and it will download it. Now by default, rubber will look for this key pair in a .ec2 directory under your home directory. And then I can move that downloaded key pair into that .ec2 directory, and I'll just call it GSG key pair, removing the .pem extension just to stick with the defaults. And then it's a good idea to change the permissions on this so it's only accessible by you. Now if you do need to change this file's name or location, you can just update the configuration here. You can just see by default it's looking under that .ec2 directory. One thing we will need to do though is make a public version of this file, so we just need to run this command to do that. So I'll paste in this command to generate that .pub file. Alright, that's all we need to change in this configuration file, but I recommend you read the rest of it on your own to see what it all does. Next, let's check out the gem file. Now here I'm going to uncomment the Ruby Racer gem line here because by default Rubber doesn't set up a JavaScript compiler on the server, so we need to use this gem to do the asset compiling. And also I want to point out that Rubber does add a few gems to the bottom of this file as well, so you'll need to run the bundle command to install all of these gems. Now that we have everything set up, it's time to deploy the application. This is done through Capistrano commands, and Rubber offers a task called create staging, which will deploy everything onto a single Amazon instance. And this is a good way to start off and try this out. So first ask me what host name to use. I'll just leave it at its default, which is production, just hit return. And then it asks me what roles I want this instance to play, and I'll just have it do everything, so I'll just hit return here to leave it at that default. So here it's setting up that instance with everything to deploy our Rails application, and this will take a little while, so just let it run. After a little while, it will ask me for a password, and this is for the user on this local machine so that it can modify the host file. So just type in your password here and then continue. And then later it will ask if it can reboot the instance. Just say yes, and continue on. So after waiting a while, the command will finally finish with the final output looking something like this. Now if the command doesn't seem to finish, SSH might have timed out. In that case, just abort it and try running the Rubber bootstrap command, which I'll show a little later. So now let's try this out by pointing our browser to production.foo.com. This is the domain name we set it up with, and this works because it added it to our host file, so this will only work on our local machine. So let's try this out. And there's our static file, which is rendered properly. Let's try visiting something dynamic at /articles. There's our scaffolding we created earlier. And let's see if this works. Creating an article. Looks like it works. It added it to the database and retrieves it successfully. Now, if you want to see the actual address to the server, check out the host file, and you can see that line that was added there. There's the IP address, and there's the other domain name that we can use if we want to access it on another machine. So this is pretty awesome. Thanks to Rubber, we've successfully deployed a Rails application with just one command. But this command is usually used for testing or staging purposes, and normally in a production environment you'll have several different instances taking on different roles. Now before I get into that, it's a good idea to terminate any instances which you aren't using. So you could do that with the Rubber destroy command or Rubber destroy all to terminate all instances for this app. And it asks me if I'm sure. I'll say yes, and poof, it's gone. Alright, so now that we've tested things out, let's create a cluster of instances, each taking on different roles. You can run cap rubber create to make an instance. First it asks me what I want to call this instance. I'm going to start by making a database server, so I'll say db01 is the name, and then it asks me what role I want this to play. I'll make it a database and set the primary option to true, as demonstrated here, to make it the primary database. Next, it's going to try to sync these security groups, and it notices some are left over from the last deploy, which are no longer required. It asks me if I want to remove those. I'm just going to say no, but there are a lot of them, so this is a lot to list out here. Now if you check out the Rubber YAML config file, you can find an option in here called prompt for security group sync, which is currently set to true. You can set this to false if you don't want to get that prompt anymore. So now the rest of the script is continuing on and is starting up that database instance. And then it will ask me for my user password again for the host file, and then it's done. So this doesn't take nearly as long because it's not fully setting up the instance, it's just creating it. So now let's create a few more instances by running that same Rubber create command. But this time I'm going to pass in the values beforehand so we can pass an alias and set the name of the instance. I'll set it to ab01, and we can pass in roles and set that to app so it takes on the actual Rails application behavior in this instance. And this time it should continue on without any prompting. And then I'll do the same thing for the web role, so I'll just pass in the name as web01 and the role as web. And this will be an HA proxy, which will delegate to the various app instances. So now with our instances created, we can set them up by running the rubber bootstrap command, and this command is idempotent, so it should only set up what it needs. You can run it as many times as you want. So this command will take a while, but it's setting up all the instances at the same time, so you can just let it run. After that's done, we can do the initial deployment by running cap deploy cold. So this will run the command on each of the servers, do the migrations, and so on. Once that's done, we can try it out by pointing our browser to web01.foo.com/articles, and when we visit this page, we get an error. Something went wrong. So let's try to debug this problem, and one useful command to help us out that Rubber provides is called tail log. So that's a Capistrano command that you can run, and this will just tail the production log on each of the servers that might exist. So here we can see the full error message. It says application CSS isn't pre-compiled. So for some reason, the assets aren't compiling on the server. To fix this problem, we need to go into our config deploy.rb file and add this line in here to set the assets role to app, because by default, the assets are only pre-compiled in the web role. Now in this particular setup, the web role is hosting the HA proxy instance, but Apache, which is supposed to serve the assets, is on the app instances. So just set this to app here. Now this will probably be set by default in future versions of Rubber, so you might not need to set it yourself. So now with that changed, we can run cap deploy, which will end up pre-compiling the assets on the app instances. And now when we hit reload, it works. There's our application. Now Rubber includes a number of useful commands that you can use to manage your instances. Run cap-t to get a list. And you can see there are quite a few commands here to perform various administrative tasks on your servers. And for example, we have cap rubber describe here, so I can try running that. And so this will list out each of the instances and their current state. Now let's say our application is getting a lot of traffic and we need to scale it. Well, it's easy enough to create new instances just like we did before. So I'll make another app instance and give it the app role. And I'll also make a separate database server, call it db02, and just give it the db role. And this will automatically take on the behavior of a slave database and replicate properly. And while we're at it, I also want to set up a WebTools instance to gather some stats about our servers. Now, if you look inside of the Rubber YAML file, you can see a commented out section here for setting a username and password to access the WebTools. So just uncomment that and set whatever password and username you want. And then I can create that instance like before. I'll just call it tools, and the role will be web tools like that. Now once that's done, we can run cap rubber bootstrap just like before to set up those instances. Now if you're ever curious about what instances Rubber is set up with and how they're configured, check out the instance production YAML file, and here you can find a list of each of the instances, what roles they occupy, and the different security groups we're using, and so on. Just a lot of good information about the various Amazon instances. Now, if you ever want to add any configuration options to a specific instance or role, check out the bottom of the Rubber YAML file. Here is a nice example commented out here on how you can set specific options to given roles or hosts. So now with the bootstrap command done, I can run cap deploy cold to set up that server, but here's a tip. If you want to run a command on only a specific instance, you can pass in the filter option and set that to the name of the instance. So in this case, app02, and that will run deploy cold only on that instance. And then I'm going to run cap deploy one more time on everything just for good measure to ensure everything is started up properly. Now that previous cap deploy cold command probably isn't necessary, but it might depend on your setup. So now with all of this set up, when we browse around the application, it's going to do load balancing between the two app instances. Rubber sets it all up automatically. We don't even have to think about it. Now, what about the tools? That's under tools.foo.com, and you actually have to use HTTPS here and specify the port, which is 8443. Now, you might get prompted for a username and password when you enter this. Just type in the same thing you did in the Rubber YAML file. Okay, so here we have access to Monet, And here we can check the status for each of our instances we have deployed. So I'll check the first app here. So this shows us our CPU and memory usage, different processes that are running, and so on. Next, let's check out HA Proxy. So here we have one instance with HA Proxy running, Web01, and we can see a lot of information here, and it shows us that it's delegating to app01 and app02 instances, and the load balancing between them, whether they're up or down, and so on. A lot of great info. Next, let's check out Graphite. Now, I wasn't able to fully get this working. You can see it says no data here. I'm guessing I just don't have enough data or haven't kept the server up long enough for it to gather data, but you can probably see graphs here with different stats about our server. And then finally, we have Graylog. So this brings up our HTTP login where we can type in the admin username and password I have set up in the Rubber YAML file. But then we come to another authentication screen, and so Graylog has its own user auth system. Now if you check out the Rubber Graylog YAML file, you can see the username and password is admin and admin1 for this, so you might want to change that as well. So I'll log in here with those credentials. And so this will show us our logs. So various logs are just piped into here. You can see that even our Rails application log files are piped in, get a lot of great info, search on it, you can do analytics, and so on. Well, that wraps up this quick look into Rubber. It's a super easy way to deploy to EC2. Now I encourage you to check out the wiki documentation because there are some really great articles that go into detail that I haven't gone into here. Also, if you're looking for a project to contribute to, this is a great one. If you have maybe some specific server setups that you like, you can create your own custom templates. I would love to see a solid template for Nginx, Unicorn, and Postgres setup. And that's all for this episode. Thanks for watching.